1,120 bird species recorded in North America today are each a masterpiece of evolution. They are the survivors of the ongoing, 2.6-million-year-old ice age. To grasp the scale of their survival, we must look at the clock. If Earth's 4.6-billion-year history were a single 24-hour day, the story of these birds happens in the final moments. Life begins early, but the world we recognize is a late arrival. The age of mammals fills the last 20 minutes. The Pleistocene, our ice age, begins at 11:59 and 11 seconds p.m. This study covers only the last 49 seconds of the Earth's day. In geological terms, the ice age is happening right now. The Pleistocene era in this chart divided into early, middle and late, and the current era the Holocene. For over 2 million years, the ice lived and breathed, advancing and receding in a massive geological pulse. Sea level drops 300 feet. At the peak of each pulse, sea levels dropped, exposing the continental shelf. North America was locked under miles of white armor. At least 4 times, the ice ground its way south, then retreated. South of the ice, the West was a pluvial world, a lush network of inland seas like Lake Bonneville. This shifting mosaic of ice and water was a high-pressure laboratory for avian evolution. For most of the Pleistocene, birds adapted to this pulse. In the early and middle periods, we know of 35 species that vanished, a slow, natural turnover of one species every 70,000 years. But this baseline is an underestimate. The true loss was likely higher, masked by the fragile bones of small birds that rarely fossilize, and perhaps more species yet to be discovered and classified. These extinctions happened due to unknown causes, long before humans ever set foot in North America. Among these early losses was Gavia cancina, the elegant loon. Its name is derived from the Latin for neat or pleasing, a reflection of its refined proportions. Physically, it was intermediate in size between the modern red-throated and common loons. It was a bird of the edges, thriving in a subtropical mosaic of marshes and shallow bays from the Atlantic to the Pacific coasts. Through this rigorous comparison, the elegant loon revealed its identity. It is distinguished from all other loons by its coracoid, a stout shoulder bone featuring a uniquely heavy-rimmed opening called a procoracoid foramen. Even its cranium and deep, upturned bill present a mosaic of features. While reminiscent of modern loons, they are distinct enough to validate Gavia cancina as its own separate entity in the fossil record. How do we breathe life into a ghost? It begins with comparative anatomy. By placing fossil remains against the skeletons of living relatives, scientists map where muscles attached and how the wings moved. For Julian, every ridge on a bone is a clue. Using data from across the continent, from the shell pits of Florida to the canyons of California, the elegant loon becomes a living being again. The elegant loon vanished during the early Pleistocene. It was a natural, lonely departure, a single note fading out long before the coming storm. To see the ghost, we must first look at the survivor. The critically endangered California condor is the last of its kind, a relict of a genus that once ruled the Pleistocene. But over 1 million years ago, a different titan patrolled the east, Gymnogyps kofordi, Koford's condor. Koford's bird was built for raw power. Compared to the modern survivor, it was slightly larger and heavier, with a wider bill and more robust limbs, evolutionary tools designed to tear into the massive carcasses of a much earlier Ice Age savanna. The proof is etched in bone. By comparing this lower leg bone, the holotype, to the modern condor, ornith-paleontologists identified specific markers, like a unique rounded rim and a longer groove in the shaft, that distinguish Koford's bird as its own ancient species. Julian's work reveals a bird that shared the broad habitat tolerance of today's condors, but vanished in the Middle Pleistocene. This was a natural exit, likely driven by shifting coastlines and the loss of the specific large prey it depended on, long before the final disaster. The double-crested cormorant is a master of today's coasts and rivers. But in the lost freshwater world of the ancient West, it had a larger, more specialized counterpart, Nanoptera idahensis, the Idaho cormorant. While their wings were nearly identical in size, the Idaho bird stood taller. Its legs, specifically the femur and tarsometatarsus, were significantly longer, a specialized adaptation for wading and hunting within the vast, shallow margins of North America's ancient inland lakes. Scientific confirmation comes from the holotype wing fragment found in the fossil beds of Idaho. It features a squared shape and a unique internal rim that sets it apart from the modern bird we see today. Julian captures a specialist that was bound to its environment. As the great freshwater systems of the early Pleistocene began to fragment and dry up, the Idaho cormorant's world simply disappeared. It was the quiet end of a specialized life, a natural turning of the geological page. The roseate spoonbill is one of North America's most recognizable birds, a flash of neon pink against the green mangroves. But the fossil beds of Florida tell us it wasn't always alone. In the early Pleistocene, a second, distinct lineage of spoonbill waded through these same marshes, Aegea kyone, the Leisey Spoonbill. While nearly identical in size to its modern relative, the Leisey Spoonbill was defined by subtle, specialized differences in its leg bones. Its tibiotarsus featured a larger, rounder distal foramen and an ankle structure built with a more steeply angled internal border. These were the markers of a unique evolutionary path. Julian's reconstruction places the bird in its home, a subtropical mosaic of fresh and saltwater marshes. The Leisey Spoonbill vanished by the Middle Pleistocene. It left the stage quietly, leaving its modern cousin to carry on the lineage alone. Another natural departure in the slow-motion history of the Ice Age. While flamingos are now icons of the tropics, they once waded through the heart of California. Standing in the shadow of the much larger Copes flamingo was Phoenicopterus minutus, the least flamingo. True to its name, it was one of the smallest species ever known, a delicate specialist of the ancient West. So far, its story is told only through the deposits of Lake Mannix, but this small species likely patrolled a much broader range of the Pleistocene West. A master of the sieve, its specialized bill filtered microscopic plankton from hypersaline shallows, supporting vast flocks that nested safely on sun-baked salt flats. Ultimately, the least flamingo could not adapt to a changing map. When Lake Mannix rapidly drained during a natural geological shift, this endemic world vanished, a natural catastrophe that silenced the flocks forever, long before the end of the Ice Age. In the arid canyons of the ancient West, another specialist patrolled the thermals. Neophrontops vallecitoensis, the Vallecito vulture. While it resembled the modern Egyptian vulture of the Old World, this was a distinctly American lineage, a trickster of the Pleistocene skies named after the Greek myth of Neophron. Named for Vallecito Creek in the Anza-Borrego Desert, this bird was a larger, more robust predecessor to the vultures later found at Rancho La Brea. It was a bridge between eras, an evolutionary forerunner that thrived in a rugged landscape of scrub and sun-baked earth. The Vallecito vulture vanished by the Middle Pleistocene. It didn't face a sudden storm, but a slow biological transition, fading into the fossil record to make way for the next generation of its kind. While modern auks and puffins fly through both air and water, the Pliocene and early Pleistocene coasts belong to a specialist that gave up the sky. Mancala vagrandis, the flightless auk. Though it resembled the modern razorbill, it had evolved into a flightless, wing-propelled diver, a true penguin of the North Pacific. The holotype wing bone tells the story of this trade-off. Its flattened shape and unique ridges prove that by the early Pleistocene, this species had fully committed to the sea. It was a highly successful design that had thrived for millions of years before its sudden decline. The flightless auk vanished as the early Pleistocene closed. It was outcompeted by more versatile, flying relatives or lost to shifting sea levels that drowned its nesting beaches, a natural, oceanic exit for a bird that once ruled the Pacific surf. Around 25,000 years ago, North America's isolation ended. Across the Bering Land Bridge, and by sea along the Pacific coast, a new predator arrived: humans. They entered a world of titans. For 2 million years, these birds had evolved alongside the megafauna, the giants that engineered the very chemistry of the landscape. As the megafauna vanished between 14,000 and 9,000 years ago, the foundation collapsed. 44 species of birds fell into the dark abyss of extinction. Multiple compounding factors drove this transition. The primary hypotheses include rapid climate instability at the Younger Dryas onset, human hunting pressure, habitat fragmentation, disease, and a proposed cosmic impact event. To look closer at this mass die-off, here are examples of some of the 44 species that went extinct during this period. The modern brant is a small, hardy voyager of our coasts. But in the late Pleistocene, it had a titanic cousin that reached the scale of a swan, Branta dickii, Dickey's goose. It was a giant of its genus, a heavy-bodied grazer of the Ice Age wetlands. This wasn't a local specialist. From the asphalt seeps of California to the shell pits of Florida and the bone caves of Maryland, Dickey's goose patrolled the entire continent. It was a dominant fixture of the North American sky for hundreds of thousands of years. Dickey's goose vanished during the late Pleistocene. As the great inland waterways shifted and the megafauna began to fail, this giant could no longer sustain its specialized life. It was one of the first 44 to fall into the dark. The tufted puffin is a familiar icon of our modern Pacific cliffs. But during the late Pleistocene, it shared these cold waters with a smaller, specialized relative, Furtercula dowi, Dow's puffin. It was a compact, powerful diver, uniquely adapted to the island ecosystems of ancient California. Dow's puffin was a master of the Channel Islands. From San Nicolas to the 17 fossil sites on San Miguel, its remains tell the story of a bird that once dominated these offshore colonies, thriving in the nutrient-rich upwellings of the Ice Age Pacific. The acorn woodpecker is a master of the modern oak woodland. But the asphalt of Rancho La Brea has revealed a tiny, extinct neighbor that didn't make it, Bitemempicus minimus, the asphalt woodpecker. It was a miniature specialist, smaller than almost any woodpecker in the West today. The asphalt woodpecker is a recent ghost, only recently named and described. It is a reminder that the abyss claimed not just the giants, but the smallest specialists of the forest canopy. It left the stage quietly, leaving its cousins to drum alone. After those last survivors fell, the record goes quiet. For 8,000 years, no avian extinctions are known in North America. This was the long silence. The silence ended with Law's diving duck. It survived the Ice Age only to face over 8,000 years of relentless human overhunting. By 2,000 years ago, the final colony was silenced, the first extinction almost completely caused by the human hand. The razorbills and murres of the North Atlantic are masters of both air and ocean. But until the mid-19th century, they shared these freezing waters with a giant that had entirely traded the sky for the sea, Pinguinus impennis, the great auk. It was the original penguin of the Northern Hemisphere. This was not a localized specialist. The great auk patrolled a vast oceanic kingdom. Yet, because it was flightless, it was bound to a handful of remote, low-lying volcanic islands for nesting, a geographic vulnerability that would ultimately become its undoing. Hunted relentlessly for its meat, feathers, and oil, the species was driven to the absolute brink. On a lonely volcanic rock off Iceland, the final breeding pair was killed for a collector's price. A lineage that survived the Ice Age was silenced in a single afternoon. Today, we think of parrots as creatures of the distant tropics. But just a century ago, a flash of emerald green, chrome yellow, and burning orange lit up the deciduous forests of the American East. Conurhopsis carolinensis, the Carolina parakeet. It was North America's only endemic parrot. The Carolina parakeet defied tropical norms as a deeply hardy, north-temperate species whose massive range spanned from Florida north to New York, and west across the Mississippi Basin to the foothills of Colorado. Divided into eastern and western populations, these parrots were strictly tethered to old-growth river valleys and forested swamps, relying heavily on giant, hollow American sycamores and bald cypress trees for communal nesting. They were highly resilient generalists, famously observed flying and foraging through heavy winter snowstorms in the northern United States before deforestation and human conflict erased them from the continent. The 1,120 bird species flying in our skies today are the ultimate survivors of the Ice Age. They weathered the glaciers, the shifting continents, and the coming of man. We cannot rewrite the tragedy of the ghosts we have lost, but we can, and must, do everything in our power to protect the living masterpieces that remain. Extinct birds of Ice Age North America. Available from University of New Mexico Press, Autumn 2027. To see more of Julian's amazing art, please go here, julianhume.co.uk/artwork.